Hi students, let's look at this question here, which was taken from the year 2018, paper 1, question 9H2 math paper. You are told that curve C has this parametric equation, and the first part is to show that dy dx is cot theta. I think that's pretty okay. So for the first part, what you need to do is actually just find dx d theta first. So dx d theta, from this expression here, what we can get is 2 minus cosine 2 theta. 2, right? And dy d theta will be a simple, this is actually y equals to 2 sine theta square. So it'll be 4 sine theta. Differentiate sine will give you cosine theta. Alright, so that's pretty okay. So dy dx will just be dy d theta over dx d theta. You could just divide it. So this is 4 sine theta cosine theta. This we could factorize the 2 out, so it's 2 1 minus cosine 2 theta. Right? This may look a bit confusing, but what we could do is actually make use of cosine 2 theta is equals to 1 minus 2 sine square theta. The reason why I use 1 is because if we can replace this as a 1, I can remove, actually this is 2 sine theta. So 2 sine square theta with 4 sine, okay, this will be cancelled away. This will be 2 sine theta cosine theta over 2 sine square theta. Okay, this would just cancel away again and cancel away 1. This will be cosine theta over sine theta, and this will just be cot theta. Okay, sure. There you go. That's how you do the first. So as for the second part, the normal to the curve at the point where theta is equal to alpha mid x-axis at point A, show that the x-coordinate of A is k alpha, where k is a constant to be found. Okay, great. I'm not sure how this is going to look like, but usually what I'll tell my students to do is just sketch using the GC for the parametric curve and just roughly understand what's going on. You may not need it, but no harm sketching it up. So I'm just going to go to math. I just want to change it to, okay, this is already in parametric. So I'm just going to clear this out. So this is 2 theta minus sine 2 theta. Okay. And this is 2 sine theta square. Now take note the window value. Your t-mean would be 0 to pi, right? So when you sketch this out with 0 to pi here, just put it pi and just graph it. Maybe zoom standard a bit. Alright, so it looks like it goes to the other side. Sorry, this is pi. Sorry, when you put zoom standard, it will go. Yeah, so this is one-sided here. So I'm going to zoom fit maybe. Maybe I'll just change the window setting here. X-min I put -1. X-max I put 6, probably will help. Oh, no, doesn't help. So I'll just put, let's say 8. And my Y-min I could just put -1. And my Y-max I could just put 5, I guess. Yeah, maybe put 3. Graph it. There you go. Now this is the graph here. So you are told to show, okay, I'm just going to put this, take this graph out. So this part here for second part, what we need is actually the theta, where theta is alpha meets x-axis at point A. So I'm not sure the normal. So I'm just going to randomly take one point, which is this point here. And this is where theta equals to alpha. Right. So when you draw the normal out, it says that this point here is this is A. Okay, so you're told to show that the x-coordinate of A is k alpha. Okay, that's pretty okay. So great. So let A be A comma 0. Okay, so we need to show that A is actually k alpha. That's the whole point there. Alright, so let's see. So when theta equals alpha, we know that dy dx is actually cot. So, or rather m tangent is equals to dy dx when theta is equals to alpha, which is actually cot alpha. Okay, so this gradient here is called alpha. So m normal multiply with m tangent is equals to -1. So in other words, gradient of normal will just be -1 over m tangent, which is actually -1 over m normal. Normal would be m tangent will be cot. So it just be negative tangent alpha. Alright. The point here, so when theta equals alpha, obviously we're just gonna have the x. The point is 2 alpha sine 2 alpha. So this point here is actually 2 alpha minus sine 2 alpha, comma 2 sine square alpha. Great. Okay, so that's about it. That's the point at the normal. So gradient of normal would be y1 minus y2, x1 minus x2. So I'm just gonna put like 2 sine square alpha over 2 alpha sine 2 alpha minus a. And I want to find a. Okay, a is what I want to find. Or this is -0 equals to negative tangent alpha. Oh, it looks like a handful, right? But this just chill and tangent alpha 2 alpha minus sine 2 alpha minus a. So I just cross multiply this up, and sine would just be 2 sine square alpha minus sine alpha cosine alpha. You could just skip step when I'm trying not to skip too many steps so that you all could follow. So this part here will be alpha here. So this will be 1. And this multiply up, there will be cosine 2 sine alpha negative cosine alpha is equals to 2 alpha minus sine 2 alpha minus a. Great. So it looks promising because this is actually this, right? So this is actually 2 sine 2 alpha equals to 2 alpha minus sine 2 alpha minus a. So a equals to 2 alpha. Okay. Yeah. So xa, hence x coordinate of a is 2 alpha. K equals to 2. That's how I do this question here proficiently. So let's look at the last part 3. You're told not to use calculator for this part here. So the distance between 2 points along a curve is the arc length. Scientists and engineers need to use arc length in applications such as finding the work done in moving an object along the path described by the curve. Okay, great. So you're told that the arc length is given by this formula. So let's see how we can do this properly. I think before that, we're just going to just understand the curve first, because now you're told to find the total length of C. First thing is look at your GC. So always check by the boundary condition, because theta is from look at the question. The question states that theta is from 0 to pi, right? So just try and trace 0 and see where is it at. It's here. So this is 0, 0. So this is actually 0, 0. Okay. Then when it's 2 pi, likely is this point here, but never take my word for it. But just this is sorry, likely is pi. Sorry. So just trace, calculate, put pi there. Trace pi. This is 2 pi. Okay. So anyway, check your value there. So when theta is pi, you know that x is equals to 2 pi minus sine 2 pi. Sine 2 pi is 0, so this is 2 pi, okay? So first thing is just to understand what's a curve C, the boundaries of the curve there, before you even start doing it. So the arc length is given by this formula here, which is actually beta gamma square root of dx d theta square plus dy d theta square d theta. Okay, great. So find the total length of C. So this part here, what you're gonna get is actually just try and understand this part. So where theta is beta between two arc lengths. So this part here is theta equals to 0, and this part here is theta equals to pi. Alright, just be sure. Okay, theta, the parameter is invisible moving force behind the parametric curve. So theta equals 0 corresponds to 0, 0, and 2 pi, theta equals to pi corresponds to 2 pi 0. Yep. So let's try and see what we can. I think it's pretty okay, because what we need to do is just put the dx d theta inside. Dx d theta is 2 minus 2. So dx d theta is actually 2 minus 2 cosine 2 theta. Then dy d theta will be 4 sine theta cosine theta. That's pretty okay. So just put into this expression here. This part here, what we're going to do is actually gonna get 2 minus 2 cos 2 theta squared plus 4 sine cosine 2 theta squared. Actually, this could be simplified. I think I will simplify this to 2 sine theta cosine theta. This is 2 sine 2 theta. I think it's probably easier. Let me just do that to 2 sine 2 theta. Okay. Because I see that this is double angle as well, so I do not want to have too many gibberish inside. Then after which we talk about the boundary condition here. Now this boundary here is important. Sometimes students get confused. Remember that it corresponds to this d theta, so this should be theta 0 to pi. That's about it. So you just put 0 to pi here. So I think generally once you get this part here, you already secure about 2 marks. Yeah, because writing the boundary condition, applying it, and understanding it. Yeah. So then the next part is to try and expand this and see how this goes. Okay. So this part here will just be, expand this will be 4 minus 8 cosine 2 square plus 4 cosine square 2 theta plus 4 sine square 2 theta. So these two could actually be 1. So this 2 is actually 4, because cosine square 2 theta plus sine square 2 theta is equals to 1, right? So this is actually 1. So be 4. So yeah, so many things, right? Minus 8 cosine 2 theta plus 4. Okay. You could skip step if you want to, but I'm trying not to skip too many steps here. So this is 1. This is 1. Okay, so that's 1. So that will be 8 minus 8 cosine 2 theta. Okay, d theta here. Then once this is done, we get 8. Then this is 8 1 minus cosine 2 theta d theta. Obviously 1 minus cosine 2 theta, we could change it using the double angle and hope that we get something out of it. I will 1 minus 2 sine square theta again. Basically this is 2 sine square theta is equals to 1 minus cosine 2 theta. So we could just simplify this into the root 8. I'll bring it out. Alright, root 8. Bring it up. This is 0 pi root 8. 1 minus cosine 2 theta would be 2 sine square theta d theta. Okay, so root 8 could root 2 could bring it out as well. So root 8 times root 2, 0 pi. Oh, you get a very simple sine theta here. So this is root 16, 0 pi, and this is sine theta d theta. Yeah. So this is 4, and this will just be negative cosine theta pi 0, and this will just be 4 negative cos pi minus cos 0. Here you go. Cos 0 is 1, cos pi is negative 1. So you get 4 negative 1 minus 0 is 1 minus 1. So this will just be 1 plus 1, which is 8. So 4 plus 2, which is 8. Okay, units. Yep. It's not I think it's not that difficult once you understood the terms properly, deciphering it. All right. So keep practicing. Any question or comments, please do let us know. See you in the next question.